Okay, in this video we're going to go right into some basics of trigonometric identities and different formulas and whatnot, starting at the very basic parts of them and then kind of expanding them out from there. So the first thing I want to do is take a look at all of these guys right here and how they related to the unit circle. So let's go ahead and get some facts that we know filled out from lessons past. Okay, so these were the definitions when we had right triangle trigonometry in the past classes, and basically it had to do with the actual angle theta and its position from, or I should say the side's positions from that, the opposite side, the adjacent side, and the hypotenuse. Okay, so when we started to line things up, we also noted that any point that's going to be on the unit circle is going to be x comma y, and we know that the side that is going to go horizontally to meet the x value is going to be x, and the side that is going to go vertically to meet the y value is y. And to make it a unit circle, because its hypotenuse is 1, we always keep that as 1 as a quality of life thing. And so what we did is that we filled in all of these definitions right here with x's and y's, so we can go back and forth between the actual trig ratio of theta, whatever trig theta it is, and move our way to x's and y's, which I'm going to list right here. Okay, so they look like that. So that is how far we made it, and what we're going to do to start off in this video is that we're going to introduce putting these x's and y, basically their values from the unit circle into the unit circle definition to create new trigonometric identities here. So, okay, so let's start proving out this first identity right here and showing why it is sine squared theta plus cosine squared theta is 1. So what we're going to do is that we're going to start with our equation of the unit circle, okay? And from there, what we are going to do is that we're going to take these values right here, oops, we can probably just, those values from x and y, and we're going to plug them in for sine and cosine in this guy right here, okay? So what we do is that sine is actually y and cosine is actually x in this case, so we're going to get cosine squared theta plus sine squared theta equals 1, okay? And then for quality of life, most people say switch them around, sine squared theta plus cosine squared theta equals 1, okay? So that basically proves out this identity right there. Now, there are two other ones that are a little bit trickier to memorize out for most students, but I'm going to show you a way to go ahead and knock those out, just using what we know about all of these other good trigonometric identities here, and start to piece them together. Before we do that, I want to go ahead and zap on over to the bottom right hand square, and I want to make sure that we got these guys down first, because that's going to be integral to deriving out these other two guys right here, okay? And all the pieces will make sense in a moment, okay? Now, the reason why tangent theta equals sine over cosine is that if we look at tangent theta, the definition, and let's go ahead and just knock these both out at the same time, and cotangent theta is that if we look at the trig identities here, is that we're going to see that tangent is y over x, and we're going to see that cotangent is x over y. So let's transfer those on over. Y over x and x over y. So now we know, again, that sine is y and cosine is x. So therefore, when we substitute them in, we're going to get the tangent of theta equals sine theta over cosine theta, and cotangent is going to equal, I don't know why I'm making my theta so sloppy, is going to equal cosine theta over sine theta. What is going on with, there you go, sine theta. So, at any rate, what we're going to do is that we're going to use those to go back to the Pythagorean identities now and see if we can come up with a slick way to memorize out, again, this guy and this guy. Okay, so to prove out the property tangent squared theta plus 1 equals secant squared theta, what we do is that we start with just the simple sine squared plus cosine squared equals 1. And what we want to do is that we think, okay, well, how do I create a tangent? Okay, and we just learned that tangent is sine over cosine. So what we can do is that we can multiply the entire thing by 1 over cosine squared theta, and when I go ahead and I distribute that into each term, I get cosine squared on the bottom of each of those, and now I can start to use the identities on this page, or this page right here, to knock everything out. Okay, so here we go. Putting all the pieces together, we're going to get sine over cosine, which is going to give us a tangent theta, and then we have cosine squared divided by cosine squared, which is going to give us 1, and we got 1 over cosine, which we know that 1 over cosine is the reciprocal value, which is going to give us secant squared theta, and there we go, we have proved out the second one. Okay, so what we're going to do is that we're going to use the same technique for the last identity, and we notice that we need a cotangent for that one. And so to get cotangent, we know that we're going to have cosine over sine, as we see right here. So therefore, what I'm going to do is that I'm going to multiply the entire thing by 1 over sine squared theta, and when I distribute, oops, that is going to give me, and I think I missed with that second one. I don't want to think it's a coefficient here. There we go. All right, so distributing that in, we're going to go ahead and get, hopefully, what we need here. So this is going to give us sine squared divided by sine squared, which is going to be 1, plus cosine over sine, which is going to give us cotangent squared theta, and then 1 over sine is going to give us cosecant squared theta. Okay, so that brings us through our basic definitions, our Pythagorean identities, and our tangent identities. So what we're going to do is that we're going to introduce some other identities, and then we're going to take a look at how do I use these trigonometric identities to rewrite something that's convoluted into something different, just for whatever reason that you may need to in the future. So see you in the next video.